Hello, everyone, and welcome to the SustainaWhat Webisode series, the City of Cape Canaveral's monthly virtual public outreach program designed to educate and inform residents about all the latest happenings regarding our local environment, technology, and infrastructure. My name is Zach Eichels, and I serve as the city's Sustainability Program Manager and Resilience Planner. Today, we will be talking about the upcoming 2021 Atlantic hurricane season, but I will not be your host for today's webisode. That title goes to Scott Spratt, the Warning Coordination Meteorologist at the National Weather Service Forecast Office in Melbourne, Florida. Scott and the forecast team over at the local National Weather Service office have been longtime outreach partners with the city, helping us to educate residents over the years about hurricane science and safety. The service they provide is truly invaluable to East Central Florida, and we thank them for all of their hard work and dedication. So Scott has prepared an excellent presentation for everyone today, and with that, I will hand the microphone over to him. Scott, take it away.
All right, very good, Zach. Thank you very much. And I'd like to start off by doing a quick review of the 2020 hurricane season, since it was so historic for our area. And I'm going to talk about the hurricane formations that have occurred in the past, historical tracks, some favored patterns. I want to talk about the 4 hazards and impacts that occur with hurricanes. And we'll take a look at the seasonal outlook, what's expected this year during 2021. And then I'm going to finalize the presentation with some resources for planning and safety awareness. So with that, let's start off by taking a look at 2020. It was a record-breaking season, no matter how we looked at it. There were 30 tropical storms last year across the Atlantic Ocean, Caribbean Sea, and Gulf of Mexico. Half of them became hurricanes, and 6 of those became major hurricanes. Those are Category 3s, 4s, or 5s. So you can see in this particular graphic the 30 named systems at the time of their maximum intensity based on satellite imagery, and then the color coding associated with the name indicates the intensity of the tropical storm or hurricane at that peak time period. So the season began with 7 tropical storms, and then starting with Hurricane Hannah through the remainder of the season and ending up in the Greek alphabet with Hurricane Iota. There was a lot of more hurricanes and tropical storms that formed once we got into about late July through the remainder of the season, which is typical for most years. As we get into the warmest months of the summer, conditions become most favorable for the hurricanes to form. The next graphic is going to indicate the tracks of those 30 tropical storms, and you can see the tracks encompass just about all the land masses of the Caribbean Sea, Central America, many locations along the Mexico coastline, and also the U.S. coastline from the Mexican border all the way up towards the Canadian border. So last year was the 6th consecutive year with preseason development, with storms forming before the 1st of June. There were 6 major hurricanes last year. It was the 5th consecutive year with at least 1 Category 5 hurricane. The Category 5 last year, ironically, was the last one that formed, Iota, and affected mainly Central America. The strongest storm that affected the U.S. coastline was Hurricane Laura. It was a strong Category 4, almost up near Category 5 intensity. And it primarily impacted the state of Louisiana. It was a area that isn't very densely populated, luckily, along the southwest Louisiana coastline. So that was a positive attribute of that storm. But once it did move inland, it brought some very strong winds and heavy rainfall to some populated areas further north into the state of Louisiana. And along the coastline, there was considerable storm surge flooding. But again, most of the areas impacted by that were unpopulated areas, thankfully. There were 9 Gulf landfalls last year, including 5 just within the state of Louisiana, and 3 Atlantic landfalls. So even if tropical storms and hurricanes last year didn't directly impact coastal areas, they at least threatened just about every portion along the populated coastline from the Caribbean to Central America to the U.S. coastline last year. This graphic is indicating all the landfall locations of those 12 tropical storms, and then the record-tying number of hurricane landfalls that occurred. So a tremendous amount of activity along the Gulf Coast, primarily across Louisiana, but also within Texas and the far western Florida Panhandle was impacted by several of the storms, and then a few weaker intensity systems affecting the U.S. East Coast. graphic spells out all the different land areas along the U.S. coastline that were impacted by either one or more than one tropical storm or hurricane watch or warning episodes or storm surge episodes. And you can see the large swath of the U.S. coastline there that was impacted by many of these different systems. So the interesting thing about last year for us here locally within East Central Florida is that even though it was the busiest season ever recorded going back over 150 years, we fared fairly well here in East Central Florida. We were impacted by two systems, the periphery of Hurricane Isaias as it passed by off our coastline at a very strong tropical storm force right around borderline Category 1 intensity. And the far western periphery of that system did bring tropical storm force winds, or at least gusts to tropical storm force from about Cape Canaveral area southward along the U.S., along the Florida coastline. And then a few months later into the season, Tropical Storm Eta came across from the Gulf of Mexico, crossed the state, north central Florida, and then moved into northeastern Florida. It was a much weakened state as it moved across the area, but it did bring tropical storm force sustained winds and gusts, mainly from about the I-4 corridor northward. So we did receive impacts from two of the systems last year, but the impacts were fairly minimal. There were really not even that much power outages that occurred from these two storms as they affected our area. So it just shows that even though it was the most active season on record, any particular geographical area may have less activity. And just the opposite can happen. It can be a relatively quiet year with tropical storms and hurricanes as a whole across the Atlantic Ocean. But if your particular area is impacted by one or two of them directly, it's a bad year for that particular location. So it really matters, where you're located relative to where the storms are occurring. Are you on the weaker side of the system, the western side? Are you on the eastern side, the stronger side of the tropical weather systems? And of course, how strong are they and how close do they come to our particular locations? So there's a lot that goes into the actual impacts that occur from these storms. Next graphic here is showing over 50 years of data composited together. And within that, we're seeing the amount of activity from tropical storms in blue, hurricanes in orange, and major hurricanes in green that occur across the calendar year. So the hurricane calendar starts on June 1st and goes to the end of November. So 6 months of the year is hurricane season. And within that 6-month period, things usually start off pretty slow during June and July most years. And it takes until about early to mid-August for the activity to start to ramp up. Then it ramps up very quickly and peaks in early September. September is a very busy month. October stays very busy. And then the trend starts to decrease as we head into late October and then certainly into November. It's interesting when we look at that 6-month hurricane season, the area defined inside of those two green lines indicate the middle of the hurricane season. So that's the 90-day period, the 3-month period from the 1st of August to the end of October. And within that half of the hurricane season, 89% of all tropical storms have historically formed then, and 94% of all hurricanes. So even though the season as a whole is 6 months long, most of the activity is occurring in the mid to the latter part of that season during the 3 months of August, September, and October. Let's take a look at what an average hurricane season would be, and then we'll talk about what this year is likely to bring for the Atlantic area. So based on the last 30 years of data for the North Atlantic, Caribbean Sea, and the Gulf of Mexico, an average season is comprised of 14 named tropical storms. So these are systems that become organized and have sustained winds of at least 39 miles per hour up to 73 miles per hour. Once the wind increases beyond 73 miles per hour, they're designated hurricanes. So in a typical year, there are 7 hurricanes across the North Atlantic, Caribbean Sea, and the Gulf of Mexico. And then 3 of those 7 typically form into major hurricanes. And those are category 3, 4, or 5, with winds of 111 miles per hour or greater. The average date of the first tropical storm is about the first week or second week of July. The average date of the first hurricane doesn't typically occur until the first or second week of August. And the first major hurricane not until the first week of September. But over the last 7 years, including this year, we've seen preseason development. That's development before the 1st of June. But when we look back over the 150 years of records from hurricanes, we find out that when preseason development occurs, that does not necessarily mean that the overall season is going to end up being above normal. It's about a 1/3 of those years tend to be above normal, 1/3 of those years tend to be below normal, and about a third of the years tend to be right about at normal in terms of the number of storms that form. So we can't use early season development as a predictor of how busy the season as a whole will be. There's a couple other factors we look at for predicting that, but this is not one of them. So just be aware of that, especially given the early season development we've seen over the past 7 years now. So this image indicates where tropical cyclones are most likely to occur or have most commonly occurred historically across the globe. And what you'll notice is the color coding. The more intense the systems are, the brighter the color coding is. So you see the bright red, that's indicating a lot of major hurricanes, category 3s, 4s, or 5s. And then when you're seeing the blue colors, those are tropical storms, and then the lighter shades are the weaker hurricanes. So the Western Pacific is where we see the most number of tropical storms and hurricanes form. The second most common area for development is the Atlantic Ocean area. And the second most likely area is the Eastern Pacific Ocean. The third most likely area is the Atlantic Ocean. It probably doesn't look it that way on this graphic. It looks like the Atlantic is more active than the Eastern Pacific. But most of the activity that occurs over the Eastern Pacific occurs in a very small area. So a lot of those tracks are overlaid on top of one another. So it doesn't look maybe as busy over the Eastern Pacific as it does across the Atlantic, Caribbean Sea, and the Gulf of Mexico. And then you can see activity either side of Australia and the Indian Ocean and South Pacific, and then either side of India and the North Arabian Sea and the North Indian Ocean. So these are the locations where the 5 ingredients become favorable for development. And the 5 ingredients are warm waters through a deep layer. The water has to be about 80 degrees Fahrenheit or greater to sustain tropical development. There needs to be weak wind shear across the area, so the system can become a coherent system from the lower levels of the atmosphere all the way up to the upper levels of the atmosphere. There needs to be a high degree of moisture in place across the region. There needs to be rising air that allows the lift to occur to cause the showers and thunderstorms to form to generally organize the tropical weather system later on in its life cycle. And then there needs to be a pre-existing disturbance in place. So a disturbance that starts the area of rotation. And early and late in the Atlantic hurricane season, those pre-existing disturbances are associated with old cold fronts that push off the North American continent and then stall over the warm tropical waters of the Gulf of Mexico, the Northwest Caribbean Sea, or the Southwestern Atlantic. And if that front stalls across that region long enough that the thunderstorms along the front will start to gather some intensity, they'll start to rotate into that pre-existing disturbance that will later on in time become a tropical depression, tropical storm, or maybe even a hurricane. When we get into the heart of the hurricane season, say October, September, and maybe even into early October, we have to look far to the east of the continent of Africa, because these are where the easterly waves or tropical waves form as clusters of thunderstorms over the continent of Africa and then spread westward across the tropical Atlantic. And when they do so, that many times is that pre-existing disturbance that allows tropical development later on during its lifetime as it spreads towards North America. So those are the favorable ingredients we need to see, and these are the areas of the globe where those conditions become favorable sometime during the year. Either side of the equator, we see no development or very little development within about 60 or 100 miles or so north and south of the equator. And that's because the storm systems in a larger scale storm system like a tropical storm or hurricane, they require some rotation added to their own circulation by the rotation of the Earth. And right along the equator, there's no additional rotation added by the spin of the Earth because we're right at the middle of the Earth. And as you get further and further away from the equator, the Coriolis force, or that background spin because of the globe, as we're getting closer up to the temperate latitudes in the North Pole and South Pole, starts to increase. And that's why we see more development in those areas. The closer we get to the North Pole and South Pole, we start to see lower temperatures and lower humidity and higher wind shear. So those ingredients become less favorable. So the favorable ingredients come together away from the equator and then away from the poles in the temperate latitudes or the subtropical latitudes. So we're going to take a quick look now at some of the more favored locations for development month by month. We'll start off during the month of June. Development tends to occur pretty close to Florida, either side of Florida, over the Gulf or over the southwest Atlantic. And again, the pre-existing disturbances that set off the rotation this time of year are these old cold fronts that push down from North America and stall somewhere either side of Florida, usually during the month of June. In July, we're still seeing some development either side of Florida from those stalled cold fronts, but we're starting to see a little bit of development further out across the eastern Caribbean Sea. And these are usually in late July as some of these lead systems start pushing from off Africa towards North America. During the month of August, all those favorable ingredients start to ramp up very quickly. We see more and more development occurring now, so August starts to be the beginning of the more active part of the tropical cyclone season. As we get into September now, things really start to peak up, and we see activity just about anywhere across the Caribbean, Atlantic, or Gulf of Mexico. The more favored tracks are indicated in the white lines, but any individual storm system can follow just about any track given the steering flow at any moment in time. But these are the more consistent or more common tracks we're seeing here on the graphic. As we get into October, the pattern starts to change a little bit. The steering winds start to come more from the south and southwest, more from the area of Central America and the Yucatan Peninsula. And during this time of year, the most favorable conditions are between the Yucatan Peninsula and Cuba. And the steering winds tend to move these systems close to Florida during the month of October. So October tends to be a pretty busy month for the state of Florida. And then November, we're more into a southwesterly flow regime. This is more typical of wintertime. And now we're seeing systems form generally to the south and east of Florida and be steered away from the state. Another way to look at the same data is I've drawn a 150-mile radius around Cape Canaveral. We're going to go all the way back to the beginning of the hurricane database in the mid-1800s and look up to the current time period and look for all formation by month within this 150-mile radius. So we'll start off by looking at the month of June. You can notice the color coding on the graphic is indicating the intensity of the tropical storms, or the hurricanes, from Category 1 in yellow all the way up to Category 5 in purple. What I'm not showing on these diagrams are the tropical storms that occur each month, but they are listed on the figure. So you can see 2 hurricanes during the month of June, but 13 tropical storms also came within that radius during the month of June. They're not shown on this particular graphic. So we're just going to be looking at the hurricanes. And this surprises a lot of people because most people think, well, June 1st is hurricane season, and that's when we start to see our hurricanes in the local area. But over 150 years of data, there's only been 2 to come within 150 miles of Cape Canaveral during that month. So not very active in June. We move ahead and take a look at July. Start to see a little bit more activity now. 6 hurricanes in that long time period, 6 tropical storms that are not shown on the diagram. And you can see their tracks across the local area. Still not too busy during July. But once we get into August, things start to increase now quite profoundly. And if you look at where these tracks are originating from, just about all of them are coming from the south and east. So they're coming from the Caribbean Sea. And that's because those pre-existing disturbances now during the heart of the hurricane season are coming off the continent of Africa, moving across the Caribbean and moving towards Florida and approaching from the south and east. There's a couple tracks coming from the south from Cuba, but most are coming from the south and east. As we get into September, a fairly similar pattern. But now you see a little bit more activity coming from the south, coming from Cuba. And these would be more likely late in September as those steering winds start to shift around to more southerly on some years. And a few tracks even coming in from the southwest, from the Gulf of Mexico. The month of October remains very busy because even though land temperatures start to cool down in October, the sea surface temperatures have about a 6-week time lag. So they stay very warm during the month of October. And now those favorable ingredients tend to come together between the Yucatan Peninsula and Cuba. And the steering winds are shifted around now to more of a winter-like pattern. So the storms tend to approach from the southwest now during October. So we have to change our attention, our focus for many of these storms and not look as much to the south and east now as looking to the south and southwest. And then interestingly, during the month of November, we've never had a hurricane come with 150 miles of Cape Canaveral. In the long database, there's one hurricane that affected far south Florida, during November and one that affected the Florida Panhandle. But that's it for the entire state of Florida during the 150 plus years of record. So in terms of hurricanes, things are very quiet by the time we get into November. Doesn't mean we can't in the future sometimes have a hurricane affect us in November, but the probability of that is very, very low. But in the past, we have had 8 tropical storms affect the state for at least 150-mile radius of central Florida during November. So we still can have impacts from lower intensity winds and heavy rainfall and some storm surge and even tornadoes. So now let's talk a little bit about the Saffir-Simpson Hurricane Intensity Scale. The scale goes from Category 1 to Category 5, and as we go up the scale, the intensity of the winds gets stronger. So Category 1 has winds of 75 to about 95 miles an hour, and by the time we get up to Category 3, the winds are at least 115 miles per hour, and by the time we get up to Category 5, the winds are over 155 miles per hour. Now, of all the hurricanes to strike the U.S. coastline, the major hurricanes account for only 21% of the landfalls. So most of them, 80% of them, are the Category 1s and 2s, the weaker hurricanes. But even with that 21% that are the major hurricanes, they're accounting for over 4/5 of all the damage that occurs along the U.S. coastline. So I want to show you another variable here that in terms of the storm intensity, this is the damage potential from those intensities. So the damage potential does not increase in a linear fashion. It increases in an exponential fashion. So from Category 1 to 2, even though the winds are increasing about 20 miles per hour, the ability of that wind to produce damage increases tenfold. And as you go from Category 2 to Category 3, the winds are increasing from 10 to 50 times. So what this is indicating is that Category 3 produces 50 times more wind damage than a Category 1. And a Category 4 produces 250 times more wind damage than a Category 1. So if our area is threatened by a Category 1 or 2 or 3 hurricane, exactly what that category is by the time it reaches us makes a very, very big difference in terms of the amount of damage and loss that it's going to cause to our local area. So it's really critical. A lot of people think that Category 2 is just a little bit stronger than a 1 and not really all that significant, but in terms of the damage, again, it's a tenfold increase in the amount of damage that can occur, so it's very, very significant. The 4 hurricane hazards that occur are wind damage, obviously. The winds bring the storm surge to our coastline, so that can be a significant hazard at times. Tornadoes also occur within hurricane rain bands. And then flooding can occur within the hurricane rain bands as well. So for a particular hurricane, all 4 of these hazards may affect a particular location, or you may be affected by 1, 2, or 3 of the hazards. It really depends on where that storm is, where the track is relative to where you're located, what side of the storm you're going to be on, how close you're going to be to the center, and then, of course, how large and how strong that storm system is. So let's talk briefly about these 4 different hazards. We'll start off with the hurricane wind hazard. This animation that you're seeing right now is Hurricane Charlie at landfall, or just shortly after landfall. This is a radar view of Hurricane Charlie. And as Hurricane Charlie began to penetrate inland, if you look very close to the center of circulation, just north of Fort Myers, you'll see that bright red area, that round ring of bright red. That's the eye wall of the hurricane. That's the most intense part of the hurricane. That's where the strongest winds are occurring, near the circulation center, just outside of the eye. So in this case, those winds were well over 100 miles an hour. At this time, about 115, 120 miles per hour sustained, with wind gusts upwards of 150 miles per hour. So truly destructive winds, life-threatening winds happening within that small round ring of bright red. If you look further away to the north or east of that area, there are other rain bands that you're seeing in yellow colors, some orange and red colors as well. And those are far outer rain bands producing very strong winds as well. But those winds are more than likely Category 1 or 2 as you get further away from the eye wall. And then by the time you get up towards that rain band approaching central Florida, say the Kissimmee-St. Cloud area or up around the Daytona Beach area, those winds are probably strong tropical storm force or low-end Category 1 force in gusts occurring within those areas. So everybody's impacted by these winds as the hurricane moves across the state. but the truly destructive, life-threatening winds occur very, very close to the center of circulation. The circulation around hurricanes in the northern hemisphere is counterclockwise. So if we envision a system coming in from the Atlantic, and let's say it's coming in towards the Brevard County barrier island from the east towards the west, to the north of the eye or to the right of the eye is where the strongest winds are going to spiral in from the Atlantic and push that water in towards the coastline, towards the barrier islands, and then towards the intercoastal waterway, and then from the intercoastal waterway towards the mainland coastline as well. And that strong increase of the winds and the water levels increases the storm surge. So the storm surge is a rapidly rising area of water. It's like a tide coming in, but the tide is coming in much, much more quickly. It's not coming in over a 6-hour period and then receding over 6 hours. It's going to be a faster push of water as that eye approaches landfall. So if we had a surge, let's say, of 9 feet of rising water due to that onshore push of the wind, and the storm came in at high tide, where we add another foot of tidal rise to the water, we're going to have a 10-foot overall storm tide. So that's water 10 feet higher due to the storm and the tide impacts. And then on top of that 10-foot rise of water are going to be the battering wind-generated waves that are going to be pushing towards the shoreline and causing a lot of damage along the coastline. So most coastal evacuations are called for by emergency management and public safety to get people out of that dangerous storm surge zone where the potential is for that rapid rise of water to occur and increase water levels to at least 3 feet or more above ground level, and sometimes much, much more greater than that. On the other hand, south of where the eye makes landfall, the winds are spiraling from the land to the sea. So the water levels are actually going to decrease south or to the left of where the eye makes landfall. And we just don't have enough scientific ability to predict exactly where the hurricane is going to make landfall. So we have to evacuate, or we have to call for coastal evacuations along a fairly large area of the coastline, much smaller than it was 10 or 20 years ago because of improvements to hurricane forecasting, but larger than we'd like it to be, because we don't know exactly where that hurricane is going to make landfall, and we certainly don't want people in an area that we think the wind's going to be offshore and that forecast to be in error just a little bit, and the hurricane makes landfall a little bit further south, and then that area turns out to be on the onshore wind flow side of the storm, and for the surge to get up to very, very high levels in that area. So that's why coastal evacuations are called for, to get people out of that potential area where the storm surge zone is likely to rise to very high levels. And of course, when that happens, it brings in a lot of seawater, a lot of sand, can move very large objects around from one area to another area. It can bring boats on shore. It can move vehicles from inland roadways and lift them with the rising water and move them to other areas. So a lot of movement of large, heavy objects during storm surge impacts. When it comes to flooding and rainfall, the intensity of the tropical storm or hurricane is not that important when it comes to the amount of rainfall that can occur. It can be a relatively weak system like a tropical depression or tropical storm and bring intense flooding, or it could be a stronger system like a Category 3 hurricane and bring very little flooding. What matters is how large is the storm and how quick does it move. If it's a slow-moving system and sprawling, it's going to produce rainfall for a long period of time, and of course the rainfall totals will add up over time and produce a significant amount of flooding. If it's a smaller system and a fast-moving system, it won't rain that long at any particular location, and the rainfall totals will not be all that significant. So just remember, flooding is not correlated with the strength of the hurricane. And all hurricanes and all tropical storms and depressions have to be treated seriously because of the impact from flooding. Most of the tornadoes that occur within tropical storms and hurricanes occur in what's called the right front quadrant, or the northeastern quadrant of the circulation. So you can think of an old-fashioned clock from noon to 3 o'clock. That 90-degree quadrant is where most of the tornadoes happen. So the example we're looking at here, again, is from Hurricane Charlie as it's making landfall. You can see the center of circulation there just north of Fort Myers. And then we've drawn on the screen that right front quadrant in between the two white lines. And that's the area where we would see the greatest tornado threat. And the tornado threat can happen fairly close to the center of circulation, but many times it happens at midpoint to long distances away from the center of circulation. So it can occur 100 or hundreds of miles away from the center. And it can occur from 6 to 12 hours out in advance of the approach of the center or the core impacts from the tropical storm or hurricane. So in this particular case, that rain band that's occurring across Osceola County, where underneath where it says threat, and then across Volusia County, just to the north where it says tornado, those particular cells were producing tornadoes at the time of this image. So again, before the closest point of approach occurs, as much as 6 or 12 hours or more. So people in those areas are making their final preparations for the approach of the center of Hurricane Charlie in this case. And as they're making those final preparations, they're being impacted by isolated tornadoes forming well out ahead of that center of circulation. The image on the right side is indicating the tracks of centers of tropical storms and hurricanes at the time they were producing multiple tornadoes across the peninsula of Florida. So all these tracks, you can see with the exception of one, are occurring to the south and west of central Florida. And this is putting that right front quadrant of those systems over the peninsula of Florida. So it's no surprise that these are the time periods where we'd have our greatest threat for tornadoes. So anytime we have a tropical system anywhere from the Keys to south of the Florida Panhandle, there is a potential for some tornadoes somewhere across the Florida Peninsula or up into the Panhandle. Okay, with all that in mind now, let's talk about seasonal hurricane forecasting. So National Weather Service makes a seasonal hurricane prediction in the middle of May every year, and then they update that forecast in early August every year, right before the peak of the season. And the forecast is made by looking at many different climate signals in the atmosphere, but the two most important ones explain a very large percentage of the year-to-year variability in the number of tropical storms, hurricanes, and major hurricanes across the Atlantic Ocean basin. So the first climate signal we need to look at is what is the warmth of the sea surface temperatures. In general, the warmer they are, the greater the number of tropical storms and hurricanes we're going to see. That allows more energy, more heat, more availability of moisture to evaporate into the atmosphere to cause the formation of the clouds that eventually will become the showers and thunderstorms and turn into the tropical storm or hurricane later on in time. The opposite occurs as well. In general, the cooler the sea surface temperatures are, the lesser the number of tropical storms and hurricanes will be because of less energy to feed into that process. This year, conditions are favorable. They're warmer than normal sea surface temperatures once again. Sea surface temperatures are predicted to be about 0.7 degrees Fahrenheit above normal during the peak of this season. Just to put it in a relative term, last year the temperatures turned out to be about 1 degree above normal. So they're not predicted to be as warm as last year, but still significantly above normal. And a 0.7 degree doesn't sound like a lot of temperature change, but in terms of the amount of available energy that adds to the process, it's a large amount. So 0.7 or 1 whole degree Fahrenheit, it makes a big difference. The second climate signal we look at is the amount of wind shear likely to exist in the atmosphere during the peak part of the hurricane season. And the El Nino phenomena provides a good proxy to determine the amount of wind shear. So in general, if we have a lack of an El Nino, meaning if we have a La Nina, which is the opposite of an El Nino, or if we have neutral conditions, which is neither an El Nino or a La Nina, and that's the case this year, we're expecting neutral conditions. Both of those conditions create a greater number of tropical storms and hurricanes because they tend to reduce the amount of wind shear. The opposite happens if we have an El Nino, because that increases the wind shear and that lessens the number of tropical storms and hurricanes that we expect to occur. Now, before I show you the seasonal forecast itself, there's a couple more caveats I want to mention. The seasonal forecast covers the entire time period from the 1st of June to the end of November, so it doesn't say anything about a particular few weeks or month. It's a composite over 6 months of time. And it doesn't say anything about any particular area. It's a forecast for the entire North Atlantic, Caribbean Sea, and Gulf of Mexico. So it's not an impact forecast or a landfall forecast. It's just saying how busy is it likely to be across the Atlantic Ocean basin as a whole. Forecasts about where storms are likely to go or how strong they're likely to be can only be made about 7 days in advance. So we can make these seasonal predictions months and months in advance about how busy, how much activity is expected across a large area over a long period of time, but not any specifics yet. So the 2021 seasonal forecast that just came out a week or two ago indicates a 60% chance of an above normal season, a 30% chance for a near normal season, and only a 10% chance for a below normal season. The expected number of named storms is somewhere between the range of 13 and 20. Remember, an average season has 14. So this is from right about average to fairly high number above average. Same thing with the hurricanes, normally 7 on a typical year. The forecast this year is from a range between 6 and 10. And typically we see 3 major hurricanes. This year we're expecting between 3 and 5 major hurricanes. So far, we had a early season, a preseason weak, short-lived tropical storm, subtropical storm that formed in mid-May, just a little while ago, and that formed on the North Atlantic, north of Bermuda. It did not last very long, but that was the first named system of the year. So if we go ahead and we look at the names this year, the first storm, Anna, was already crossed off the list with that short duration storm that just formed. The next name on the list is Bill. And the name list is 21 names. There's 6 individual name lists that are available, and then we start over again. So every 7th year, the name list will reappear unless a name is retired off the list. So 7 years from now, the list will be used over again, starting with Anna. If storms are retired off the list, that happens because the impacts are so significant that that name is, we don't want to use that name again. We're going to retire that name, so it's not put back in the name list, and it's replaced by a new name. I want to mention a few resources for planning and being aware of what the threats are as we go through the hurricane season. So the first place is the National Hurricane Center website. I'm sure many of you have been there before, but if you haven't been, when you get a chance, please check it out, nhc.noaa.gov will bring you to this website. And on the website, you'll see a 5-day tropical weather outlook. It's updated every day, 4 times a day, from May 15th through the end of November. So it's every 6 hours. This graphic is updated. If there's any tropical activity, it will be displayed in this graphic with an area of formation indicated graphically. This website also includes the track and intensity forecast whenever there is a tropical storm or hurricane anywhere across the Atlantic Ocean, and those forecasts are updated every 6 hours. So you can see the track and the intensity and the movement of those storms. It indicates watches and warnings in effect for different areas of land. The website also indicates tropical storm and hurricane wind speed probabilities, so you can look at a location close to where you live or work and see what the probability is of receiving tropical storm and hurricane force winds. And again, that's updated every 6 hours. So you can watch the trend and see, is the trend increasing? Is it increasing quickly or slowly? Or maybe it's steady state, or maybe the trend is decreasing probabilities, which would be a good thing. And then there's graphics showing the most likely arrival time of tropical storm force winds. So for your planning purposes, what time are the tropical storm force winds? The winds of 39 miles per hour or greater are likely to arrive in your particular location. So you can make sure you have all your sheltering done by the time those winds arrive. So really, really helpful information. And there's also information on the rainfall and storm surge expected. Now, in addition to the National Hurricane Center website, for local information about Brevard County or Northern Brevard County or Cape Canaveral, you can go to the National Weather Service Melbourne website, and that's weather.gov/Melbourne. And from this website, the National Weather Service meteorologists at our office in Melbourne are going to start with the National Hurricane Center forecast of the track, the intensity, and the structure of the storm. And then we're going to downscale that information to the individual counties and cities across East Central Florida. So we're going to provide very detailed information, certainly inside of 48 hours, and then the information becomes more accurate and more detailed as the storm gets closer and closer to our area. We provide sub-county scale planning forecast, which is called the reasonable worst case scenario. So that's what I'm showing on the screen right now, is that you can look for wind, storm surge, flooding, and tornadoes, and look in your particular area and see what the expected reasonable worst case scenario is. And what this tells you is this is a safety margin forecast. It's a planning forecast. So the forecasts are not 100% accurate. We all know that, especially if you get out beyond 48 hours until time of impact. So what we don't want you to do is take the most likely forecast of, say, maybe 50-mile-per-hour winds and plan for that, and then find out later on that the storm unsuspectedly increases to maybe a Category 1 or Category 2 at landfall, and you're not prepared for those higher intensity winds. So these graphics take that into account. They take into account what is the potential. So the potential for a hurricane, it's not going to be always Category 5. The potential may be a Category 2 or Category 3 for a given circumstance. So maybe the forecast is for Category 1 winds, but the potential is a Category 2 or 3 winds are possible in your area. So you plan for that, and then you hope that the forecast turns out very accurate and the winds are only Category 1 at the worst. So it allows you to err on the side of caution with these planning graphics. Here's a closer up view of one of the graphics, and this is for the wind hazard. So in this particular example, the potential for East Central Florida, all of East Central Florida, and Brevard County in particular, is for winds of Category 1 or 2 intensity. And you can put your mouse cursor over your particular area on this graphic and see two things. You can see what is the planning forecast, what is that realistic worst case scenario forecast that you should plan for in case the forecast is in error. And then what is the most likely forecast? What is the most likely outcome? So assuming that the forecast was absolutely perfect, what would the winds be in your particular area? And again, these are updated every 6 hours, so you can watch for changes. Is the threat to your area increasing or decreasing, or is it steady state over time? So they're really, really good planning tools down to the local level. And one thing I want to mention at the close here is that one change to the hurricane program starting this year in 2021 is that the Greek alphabet has been retired. There's a number of reasons. Some controversies that developed with the use of the Greek alphabet last year, some complexities, some difficulties in the use of the name list. Remember, it was used one other time back in 2005 and then again last year. So what was determined after last year because of the controversies and the issues that developed is that a new supplemental name list will be used. It will not be the Greek alphabet anymore, and you can see that name list here at the bottom of the screen. So hopefully we won't have to go beyond the initial name list anytime soon, but if we have to in the future, we will use the names from this list instead. So maybe a couple of years from now, we have to use a name or two on this list, and then hopefully for many, many more years, we don't have to use the list again, and then maybe 5 or 10 years down the road, we have to consult this supplemental list and use some names from the list again. So it shouldn't happen very often. Again, we're expecting above normal season again for 2021. We're not expecting the amount of activity to be anything near last year, so we're not looking at record-breaking number of pushing up near 30 storms again this year, but we are looking for more storms than a typical year. Again, that would be 14 tropical storms, 7 hurricanes, and 3 major hurricanes. And remember, we cannot predict what areas they'll impact months in advance. They can only be done about a week in advance, and then the forecast becomes more precise as we get closer and closer to time of impact. So a reminder as we wrap up here, every storm is different when it comes to the impacts and the impacts that will occur where you're at. So it's really important, what is the storm track relative to you? Is the storm going to track east or west of you and put you on the stronger or the weaker side of the system? Are you going to be impacted by 1, 2, 3, or 4 of the hurricane hazards, and so on? So please don't let past experiences determine your future actions, because if you're thinking about a past storm that affected your area, and this storm looks like it's going to do the same thing, you may end up being just, the storm may pass just west of you this time instead of just east of you, and that can make a very, very big difference, even though the intensity of the storm is the same category as the one you remember from the past, and even if the track is very similar, it really makes a big difference. So plan, prepare, and then follow through with your plans. Don't stop, don't change your plans. Once you've made them, follow through and finalize those plans. Thank you for listening to the presentation. We want you to stay safe this hurricane season, and please, again, plan, prepare, and follow through. Thank you very much.
Hey, thank you, Scott. That was fantastic, as always. Thank you so much. Do you have any time for some questions?
Sure, absolutely.
Okay, I have some prepared here. From a lot of these questions come from previous engagements with people, or just some common questions we often hear during summer when the hurricane season starts. Why this one's interesting. Somebody asked, why do you seem to not see lightning or hear thunder in hurricanes when they make landfall?
Yeah, it's a really good question. A tropical weather system is what we call a warm core weather system, since it's originating in the deep tropics. The air very close to the center and even out to the outer periphery of the system is made up of very warm air at the lower levels, but all the way up into the upper atmosphere as well. So typically outside of a tropical weather system, temperatures fall quite rapidly as you get higher up into the atmosphere. So on a typical afternoon in the summertime in Florida, temperatures at 10,000, 20,000, 30,000 feet above the ground are relatively cold. And that temperature difference between the ground level and the upper atmosphere allows the water droplets inside of the storms to freeze because it's below freezing above the ground. And when the water droplets freeze, they acquire a different charge than the precipitation that's non-frozen. And the difference between the charge between the rain droplets and the ice particles in the upper atmosphere allows electrical current to form, and that's how we get our lightning. So the upper atmosphere has to be comprised of frozen precipitation, has to be hail in the upper atmosphere, and then the water droplets in the lower atmosphere to cause electrification to occur and to cause the lightning to happen. And in a tropical weather system, it's warm all the way up to the top of the atmosphere. So typically the storms aren't getting up to the level of freezing that's producing these particles of hail in the upper atmosphere.
Very interesting. Another question that we always get this actually is, and you've probably heard this one too, is what is the influence that climate change is having on Atlantic hurricane activity? Is it causing more storms? I noticed the averages have gone up in the newest 30-year climate norms. What do you think is the influence there, if any?
And there's been a lot of research on this, and the research continues. The conclusive research that we have at this point in time is that with the warming ocean temperatures and warming atmosphere, that we're likely to see more stronger hurricanes, so more Category 3s, 4s, and 5s. In terms of a number of tropical storms and hurricanes overall, we're not seeing that in the data at this time. So overall, the numbers of storms are not likely to increase that much, but we're likely to see more stronger storms. Also, we know that with a warmer atmosphere, that the storms can hold more moisture. So it's very, very likely that they will produce more rainfall. So we'll see more events with flooding from heavy rain than we've seen in the past with a warming atmosphere. And also with sea level rise, we'll see more coastal flooding along the coastline than we've seen in the past. So there are some impacts happening there. In terms of the number of tropical storms and hurricanes increasing, they have increased over the last 30 years or so. And that's mainly due to the fact that our technology is getting better. We have better sensors, better satellite data that we can see the storms. For example, the subtropical storm Anna that formed just a few days ago in late May this year north of Bermuda likely would not have been named a system many, many years ago because the technology wouldn't have allowed it to be sensed in the atmosphere since it was away from any land areas. It probably would not have been designated the tropical storm or subtropical storm a long time ago. So the numbers that we're seeing tend to be an increase in the weaker systems and shorter-lived systems versus the more significant ones that are occurring that we need to be more concerned about.
Okay, very good to know for planning purposes. Another one that we get is, and I don't know if you have the answer to this offhand, but what would you consider to be one of the most costliest and maybe impactful storms that have ever hit Brevard County on record that you know of?
Yeah, that's a good question. I don't have that information in front of me. Usually when a system causes a lot of water damage, in terms of dollar value, those produce a much higher damage total than just wind related itself. So it probably would not be storms that would come to your mind. The stronger wind intensity storms is probably of these slower moving, sprawling, weaker systems that produce the tremendous rainfall across the area, like a tropical storm Faye event that occurred over a decade ago. So probably not the big name storms that you think of, because the damage typically comes more from water related damage versus wind related damage.
Okay. We saw this question too pop up. There was talk of moving the start date of the hurricane season to May 15th from June 1st. Has there been any traction around that, or has that been dropped at this time, or what can you speak to that?
Yeah, it was discussed this year. It was decided this year, 2021, that change would not happen. So hurricane season still is June 1st to the end of November. It's still being discussed, still being debated, and I think that will continue for a while longer. I don't know the outcome, how that will change in future years. It could be as early as next year. The season is designated May 15th, or may take a few more years, or it may not change at all. The idea for not changing it, the rationale for that is that even though we're seeing lately over the last 7 years for sure, but even over the last 10 or 15 years, we're seeing more early season development. Those storms tend to be relatively weak. So they're tropical storms. They're not producing a lot of significant impact. Those are still occurring during the middle to latter part of the hurricane season. So until the impact becomes more significant, that's some rationale for not changing the season. Another reason for it is it's hard to focus people and get people's attention with a 6-month-long season, because it is half the year, and then adding an additional 2 weeks or so to the season is going to make it even harder to focus people's attention on that, especially if the impacts are relatively minor early in the season when they are forming earlier. So I think we just have to stay tuned as more information comes in and the issue is debated more. We may see a change over coming years, or we may not. There may be enough rationale to not make that change because the impacts are relatively low, and still we want the concentration to be on the mid to latter part of the season where most of the significant impacts occur.
Okay, so we'll stay tuned. And then the last question we have is, we see all these incredible satellite images and views from space. What is actually photographing and measuring these storms from space? Is this one particular satellite, or is it a fleet of satellites that work together? How does that work?
Yeah, there are a couple of different satellites. The primary satellite, which does most of the work, is a satellite that was launched about 5 years ago from Cape Canaveral. It is in a geosynchronous orbit, meaning it's rotating at the same rotational rate that the Earth is. So it's 22,500 miles above the surface of the Earth, and being in that height, it revolves at the same rotational rate of the Earth, so it gives the same footprint. It's looking at from an area over the eastern Pacific Ocean all the way to the western coast of Africa. So it's basically looking at that whole half of the hemisphere, and it looks at that same area all the time. And that's what's giving most of our satellite imagery. But there's other satellite sensors. There's global orbiting satellites that rotate around the Earth, around the poles, North Pole and South Pole, and then the Earth is rotating, beneath it constantly. So we get strips of data from north to south along strips of the globe, and that continues throughout the day. So sometimes the satellite's in the right place for those global orbiting satellites to get an image right over the hurricane. Other times it misses it, because when it passes over that particular area, it's east or west of the center of the tropical storm or hurricane. There's microwave sensors on some of the satellites now where they can see through the clouds, and they can make an estimate of what the winds are at ocean level below the clouds. That's something we didn't have many, many years ago. And that helps out by estimating some of these systems away from land, like I talked about with subtropical storm Anna this year, that if we didn't have access to that type of data, we may not have had data indicating that the winds were strong enough to name that system a subtropical storm. So there's many, many new technologies out there. There's unmanned aerial surveillance, different types of drones and gliders that are being flown near tropical storms and hurricanes, some within the environment of the system, and some sondes and different systems in the ocean itself, either at the ocean surface or down deeper into the ocean, to determine how much oceanic heat energy is available to evaporate up into the atmosphere for formation, intensification of storms and hurricanes as well. So a lot of great technology being applied, and a lot of this technology is very new. We're still learning from it. We're still learning how to use the technology best to be able to make forecasts of intensity change going forward in time.
Okay, yeah, that's incredible. Well, thanks again, Scott. We really appreciate you joining us today in preparation for the next hurricane season. Hopefully, kind of like last year, we won't really have anything that impacts our immediate area. But we know you'll be watching our backs from Melbourne. So thank you very much, and we appreciate everything you do.
You're very welcome. Thank you so much, Zach, and appreciate the partnership with you all.
Yes, no problem. Have a great day, and goodbye, everyone.